In financial markets, big things are supposed to happen slowly. A 10% move in major national index is the great year. A 20% move is a bubble. But what happened in South Korea over the last 9 months is not a bubble. It is a mathematical anomaly. In April 2025, the KOSPI index was sitting at roughly 2,300 points. It was dead money. Foreign investors were leaving. The country was being written off as a demographic cliff. But by January 22nd, 2026, less than 9 months later, KOSPI shattered the 5,000 point barrier. This is not a rally. This is a 119% vertical surge in a G20 economy. This is the kind of move you see in a meme coin, not a $1 trillion stock market. If the S&P 500 did this, the global economy would be in a state of shock. Most analysts are calling this hype. They're saying it's spillover from Nvidia. They are wrong. This surge is the global market finally pricing in a physical reality that engineers have known about for a decade. We have hit a heat wall. We have built AI processors, the brain, that are fast enough to simulate godlike intelligence. But we forgot to build the blood vessels to fit them. We have solved compute, but we have failed at transport. The entire AI revolution is currently being choked by a single bottleneck. It's not data. It's not electricity. It is the physical heat generated by moving information from point A to point B. And right now, there are effectively only 2 companies on Earth, SK Hynix and Samsung Electronics, that have the technology to stop the entire system from melting down. This isn't a stock story. This is a thermodynamic story. Welcome to Growth. I'm Sean, your guide to money and navigating the frontier of innovation. Today, we're going to talk about the entropy trade and deconstruct the KOSPI anomaly. First, we are going to break down the von Neumann prism. We will look at the specific architectural flaw in every computer on Earth that turns data movement into wasted, and why this flaw is the single biggest threat to the AI economy. Next, we will go inside the civil war of manufacturing. We will look at the microscopic battle between SK Hynix and Samsung, the glue technologies that determined why one company is up 300% and the other is just catching up. And finally, I will show you how key companies are positioning. We will move beyond the index and look at the pick and shovel plays, the equipment makers who have a monopoly on the machines that build these skyscrapers. To understand why a stock market in Seoul just doubled in value, we have to forget about the finance for a moment. We need to go back to 1945 and talk about John von Neumann. Von Neumann gave us the architecture of the modern world. He made a brilliant, efficient decision. He separated the thinking, CPU, from the remembering, memory. He connected them with a bus, a set of wires. For 7 years, this was perfect. You load a program from memory, send it to the CPU, process it, and send it back. But then came deep learning. A large language model like GPT-5 is not a program in a traditional sense. It is a massive matrix of weights, trillions of them. To calculate one single token of text, the GPU needs access to these billions of parameters instantly. It needs to remember everything, all at once. And this is why von Neumann architecture turns into a prison. This is the von Neumann bottleneck. The GPU is now so fast that it spends 50% of its time idling, just waiting for the memory to arrive. But the problem isn't just the speed, it's energy. In chip physics, the energy cost of an operation is directly proportional to the distance the electron has to travel. Moving data from an external RAM stick to the GPU costs roughly 100 times more energy than performing the actual floating point calculation. Let me repeat that. 99% of the power consumed by an AI data center isn't being used to think. It is being burned as wasted just to shuttle data back and forth across a few centimeters of copper wire. This is the entropy tax. As we scale to bigger models, this tax becomes unpayable. If we kept using traditional memory, DRAM, an AI cluster would require a nuclear plant just to cool the wires. We didn't need a better chip. We needed to delete the distance. The industry realized that we couldn't make the electrons move faster. So we had to move the warehouse closer to the factory. This is HBM, high bandwidth memory. This isn't a chip, it is a skyscraper. Traditional memory is like a sprawling suburb. Single-story houses spread out on a flat plain. HBM is Manhattan. Samsung and SK Hynix stopped building out. They started building up. They stack 8, 12, and now 16 DRAM dies directly on top of each other. But the real engineering miracle isn't the stacking, it's the elevator. To connect these layers, they don't use wires on the outside. They use lasers to drill microscopic holes through the solid silicon itself. These are called TSV, through silicon via. Imagine a skyscraper with 50,000 elevators. That is an HBM stack. A standard stick of RAM has a 64-bit wide path for data. An HBM stack has a 1024-bit wide path. But here is where the story gets violent. Stacking chip is pretty easy. Keeping them from breaking is hard. For the last 3 years, there has been a civil war in Korea over how to glue these layers together. And this specific engineering decision is why SK Hynix stock is up 300%. And Samsung has been playing catch up. Samsung chose a method called TC-NCF. Think of it as placing sticky film between every layer and ironing it flat. It's precise, but it's slow. And worse, the film acts like a winter coat. It traps the heat inside the stack. SK Hynix looked at that and said no. They invented something crazy called MR-MUF. Instead of ironing each layer one by one, Hynix stacked the chips with tiny gaps, and then they inject a liquid epoxy, like magical glue, that flows between the cracks and hardens. This liquid doesn't just hold the chips, it dissipates the heat 30% better than Samsung's film. This one engineering decision made SK Hynix the king. They didn't just build a chip, they built a better heatsink. But now, we are approaching the limit. For HBM4, the stacks are getting so high, 16 layers, that even the glue is too thick. So we are moving to the end game, hybrid bonding. We are going to stop using the glue entirely. We are going to weld the copper of layer 1 directly to the copper of layer 2. No bumps, no gaps, just pure metal fusion. Whoever masters this atomic welding first wins the 2027 market. Now, let's zoom out to the market, because this technical war has created a financial superstorm. For the last 2 years, SK Hynix is the king because of their superior gluing MR-MUF. They are the primary supplier for Nvidia's H100. Last month, Nvidia CEO Jensen Huang made an emergency visit to Seoul. He didn't come for a vacation. He came because he's terrified of supply. He met with Taewon Che of SK Group and Jay Lee of Samsung. Why? Because the demand for the next generation, HBM4, is so high that SK Hynix physically cannot build factories fast enough to meet it. They are sold out for the next 18 months. This scarcity has triggered the death of the Korea discount. To understand the KOSPI 5000, you have to understand these curves. For decades, Korean stock traded at half the valuation of US stocks. Why? Because they were cyclical. Investors treated Samsung like a commodity miner. They made money 1 year, lost it the next. But Jensen Huang's visit proved something. HBM is not a commodity. It is a critical infrastructure. Now you don't buy Samsung because you hope people buy more phones next year. You buy Samsung because if you don't, your $50 billion AI cluster turns into a paperweight. This shifted the asset class from cyclical memory to structural utility. The KOSPI didn't just rally, it was repriced. The market is effectively saying that Korean silicon is now as essential to the global economy as Saudi oil or Taiwanese logic chips. And don't forget Micron. Micron is the triopoly player. They are the only US-based manufacturer. While Samsung and Hynix fight over yield, Micron is skipping early manufacturing mass and going straight to the advanced nodes. They are currently hovering around 9 to 10% market share. But with the US CHIPS Act, they have the supply chain security hedge. If war breaks out in the Taiwanese Strait, or if the Korean Peninsula destabilizes, Micron is the only backup plan the West has. I have given you the super bullish thesis. I have explained why the KOSPI doubled. Now, I need to tell you why this might be the most dangerous trade on Earth. We need to distinguish between a solution and a band-aid. HBM is a miracle of engineering, but effectively, it is just very expensive, very hot band-aid on a wound that is festering. The wound is the von Neumann architecture itself. We are currently trying to stack 16 layers of silicon. The physics of this is nightmare. The layers in the middle of the stack effectively have no way to cool down. They can get 76% hotter than the bottom layers. If that temperature hits the critical threshold, the bits flip, the data corrupts, and the AI starts to hallucinate. To prevent this, we are lowering the clock speeds. We are throttling the very performance we are paying for. Also, there's the yield trap. Industry rumors suggest that the yield rates for HBM3E are still hovering around 60 to 70%. That means for every 10 chips Hynix makes, 3 or 4 go in the trash. For HBM4, with its complex logic integration, that yield could drop even lower. If the yields don't improve, the cost of AI compute doesn't go down, it goes up. And that brings us to the existential risk. HBM is the peak of the current paradigm. It is the absolute limit of how far we can push electron-based von Neumann computing. But the real future, the physical AI future, might not use this architecture at all. I mentioned neuromorphic computing. You probably rolled your eyes. That's 2030 stuff. It may not. Look at IBM's North Pole. It doesn't use HBM. It doesn't have a memory wall because the memory is dissolved into the compute. In tests, it is running image classification 25 times more efficiently than an Nvidia GPU. Or look at Intel's Loihi 2. These chips are effectively cold. They don't need the massive cooling towers. They don't need the HBM skyscrapers. Right now, they are small. They cannot run GPT-5. But if IBM or Intel figure out how to scale this architecture, the entire HBM industry, the 5,000-point KOSPI, the trillion-dollar valuations, collapses in a moment. We are betting the global economy on better horses, HBM, while few guys in a lab are building a car. So, how do we trade this market? Most investors are chasing the index. They see the KOSPI at 5,000 and they experience FOMO. But if you're watching this channel, you're not here just to buy the index. There are 3 layers in the HBM stack. First, you have the incumbents. If you want the safety of the new era, you look at SK Hynix. They're the new ExxonMobil. They have the contracts, they have the yield, and they have the cash flow. If you want alpha, if you want a bit riskier, higher reward bet, Then you look at Samsung. They're currently priced at discount because of their glue problem. If they solve the yield problem, their stock will re-rate violently. It is the classic turnaround play. Second, you have the arms dealers. This is where the real money is made in a gold rush. You don't dig for gold, you sell the shovels. In this case, the shovel is TC bonder, the machine that physically presses these chips together. Look at companies like Semiconductor. They have a near monopoly on the equipment that both Hynix and Micron rely on. This is the ASML of bonding. And third, you have the consumables. This is the layer most retail investors miss. You can sell a machine once, but you sell the chemicals every single day. To make a 16-layer HBM stack, you have to polish each layer down to a fraction of a human hair. That requires massive amounts of CMP slurry, and you need specialized precursors to deposit copper. Look at players like Solbrain and Dongjin Semicam. These are the companies that feed the fab. They are the boring, high-margin compounders that will be inside every single HBM chip for the next decade, regardless of who wins the memory war. Let me leave you with this final thought. The KOSPI hitting 5,000 isn't just about Korea. It is a signal that the global trade is shifting. For the last 15 years, the greatest way to build wealth was to own IP, intellectual properties. You wanted to own the design, the brand, the software code. You wanted to be Apple or Nvidia in California. You didn't want to own the factory. The factory was low margin. The factory was hard. That logic just inverted. We're entering the era where execution is scarcer than ideation. It is becoming very easy to design a chip. AI can do that now. But it is becoming exponentially harder to actually build it. The bottleneck of the global economy has moved from Silicon Valley to the industrial corridors of East Asia, from the mind to the hands. The market paying a 100% premium for Korean equities is the market, realizing that in a physical AI world, if you cannot build it, you don't own it. So, here's the question for you. Is this the beginning of the hard tech decade, where manufacturing outperforms software? Or will the value eventually flow back to US designers once the supply chain stabilizes? See you in the comments below. This was Sean from BuySpark. If you enjoyed the video, press like, subscribe, and hype does matter. And if you want a written version of this video with full references, subscribe to our newsletter. Thank you for watching. Until next time.